Thanks everyone for joining. Depending on where you are joining from. So, good evening, good morning, good afternoon. I know, things are not as usual, a little bit tough days for people all over the world because of the COVID-19 situation. People are working from home, kids are home, brought in different challenges for all of us in our daily life. But I appreciate that, you are, spending some time and take up some time from your busy schedule to do some learning. So I will be talking about Cardinality Estimator, and before I start, so this is a program that has been put together by a bunch of MVPs in order to support UNICEF. So please, you can scan this QR code and try to see if you can make a donation. That will be highly appreciated. These are some of our sponsors. So if you have a need for any of their product, please do visit them. Because of this kind of sponsors, a program like this can be brought to the technologists all over the world for free of cost. Okay, so I am a little bit challenged with this. No. Okay. We're definitely looking for your feedback. So the left QR code is to give feedback about me. I would appreciate if you give, constructive feedback. Means if you like it, tell me why. If you do not like it, that's absolutely fine. Or any suggestion for improvement, but give a reason. Because if you just tell me you didn't like it and and why you didn't like it, that really doesn't help any of us. On the right side is the event feedback. I'm sure the organizers are looking to find out what went good, what didn't go well, so they can improve next time they host something like this. I'm not going to talk about myself in details on the right side. You can read about if you're interested, but I'm more interested about letting you know my contact, because you only have about 50 minutes. If I did not answer any question, or you had a question that you didn't get a chance to ask me, or you are not happy with my answer, or if you have a different opinion, any of this, feel free to contact me, let me know, and I'll make sure that I'll get back to you probably within 2 days. So this is some kind of the agenda we're going to talk about. First couple of definitions, and then what is cardinality, why cardinality matters, because if you do not know why it matters, this talk, there's no reason to listen to me, right? So I'll try to make a case that why it is important and why you should understand. Um, and we'll look at DBCC show statistics, which is a major source of for the cardinality estimator to estimate number of records that qualify while execution queries, while executing queries. And then, the lastly I named it as the magic number. So we look at, we'll go to demo and we'll look at bunch of execution plan and look at a bunch of numbers and try to make sense where those numbers are coming from. So predicate, it's the expression that we all, or we use all the time in our queries. A predicate can be a true, false, or unknown sometime to the when the plan is getting generated. The query engine doesn't know during the compilation time if it's going to be true, false, or it's going to be, if it's going to be unknown. And there is some implication on that. And there are two different types of predicate. One is a join and one is a filter predicate. And a filter predicate, I gave an example here, pretty simple T-SQL. We can put in a where clause. We're looking at order date of January 1st, 2013. And then we're doing a group by, but after the group by, we can do some more filtering. We are saying, only give me the records where count is more than 2. And next, another important thing to understand is the density. So what's the density? It's pretty much, we're talking about the uniqueness of our data within a column. So how many distinct values we have. The more distinct values we have, the less rows are going to qualify when we are using our predicates. In general, I'm speaking. So the definition is, 1 upon the distinct values in a column. As you can see here, I'm saying, give me, distinct customer ID, which is 663. We divide 1 by 663. We get that 0.00150830. That's the density for that column. And you will see that during DBCC show statistics, and even during making assumption about cardinality during query execution, this number will be used over and over. So now we talk about predicate, we talk about density. The another term to understand is the selectivity of a predicate. So we are saying customer ID is 577, and the query engine wants to know how selective is customer ID. And the way we do a calculation is, there's 75 rows come out of 73,595. So in this case, the selectivity is 0.001. The lower the number, the better it is, for a query execution. Now, the topic is, cardinality estimator. So what's a cardinality? And cardinality is a very generic word. And when I say generic, it's really not unique to our, to our discipline. It's not unique to data professionals. There are mathematicians, there are other people, they all use this word in their own way or in their own understanding. So I kind of picked 3 from different sources, and I think these 3 kind of covers pretty much, in the context of database. So again, it's the number of rows written by a query operator, but as we always talk about, like SQL Server engine or the T-SQL is a set base. So there's, I put a definition for, in a set. If we look at the number of elements in a set, they call this, that's the cardinality of that set, and which kind of aligned with what we are talking about in terms of table and records. So why we're talking about this? So this is a picture from a execution plan. If you hover on operator, you can see this, a clustered indexing. Now, if any of you are not aware of, or you do not know what's the execution plan, or you really do not know how to read some basic reads of an execution plan, this talk may be a little bit difficult for you to follow, but I'm not trying to scare you. I'm sure you will learn something. But if you do not know, I highly suggest, there is a gentleman named Grant Fritchie who works for Redgate. He actually has a book that is about 700 plus. The PDF version is free to download. I highly suggest you to download that book and go through it, because that book really covers execution plan from very basic to a very high level. It can go to very complex level. So what are you looking at here? We are saying this cluster index SIG, when the query plan was being generated, the cardinality estimator estimated that 7.61577 rows will be qualified. So you can say 8 rows will qualify. And when this query executed, the runtime, during runtime, we found out that actually 12 rows qualified. Now, is this a big deal? Absolutely not. 8 rows versus 12 rows. But imagine if this was 8 million versus 12 million, or if this was 1 million versus 12 million. Do you have a problem? Yes. So our goal always is to see that estimated number of rows and actual number of rows match. That's the ideal. But is it going to happen all the time? Absolutely not. Why? I'll show you during the demo. Also during the during the presentation. So the reason I'm giving this talk, or I want you to focus on, is how do you know that where this number 7.6 is coming from. If you know that, where it's coming from, where's the source, and then when you see a bigger discrepancy between the estimated number and the actual number, you can do something about it. You can try to fix it. You can try to influence it. Um, or you might try to rewrite your code to in a different way. And all of this, so these two numbers, if they are widely varied, there is implications, and we'll talk about it. Now, when you submit a query at the first, what happens is a parse and normalize. In a parse phase, SQL Server just check the syntax. It even doesn't check if the table exists. If you just say, a table name and it's the wrong name, at a parse phase, SQL Server has no idea that this table doesn't exist. It happens in the normalized phase. In normalized phase, SQL Server go and make sure all the objects exist. If you have a view name, it kind of replaces the view with the view definition. It might do some inlining in 2019. So it does all that and then pass it to the Cardinality Estimator. So what does the Cardinality Estimator does? It tries to understand, tries to find out how many rows are going to get qualified for each of the operators. And based on that, it creates many different plans. How many? We don't know. Because the possibility is huge. It's 2 to the power n if you have n number of joins. So, it grows is very quickly, the number. But SQL Server doesn't try to find out all the plans and then compare the cost of all these plans. Then most of the time we'll find out that SQL Server is spending more time generating plan, comparing plan, choosing a plan than really doing the work. So that's not practical. So what SQL Server does, as soon as it finds a good enough plan, it moves on. It keeps moving on. Then it goes to optimization and then execution plan. Now, as you can see in this pipeline, it is important that the derived cardinality phase happen a lot earlier. And if that phase pick up wrong estimates, huge discrepancy, then everything followed by that is going to affect it, right? So that is why that phase is important for us, that the cardinality, when it's deriving, it gets as better estimate as possible. So we get, more closer number, closer towards the actual numbers. So what's the impact, right? If we choose a wrong number or the estimates are way off than actual, there are a bunch of implication. First, based on the cost, there's a setting called cost threshold of parallelism. A lot of people call it setup. And that number dictates if an execution plan will go in parallel versus serial execution. So if my estimates are too high, then SQL Server will make a parallel plan, but when it goes and see that the actual numbers are low, I'm really wasting resource, right? And sometimes if a plan is not really worthy of parallel execution, you send it there, sometimes you will be spending more time coordinating between the parallel threads than really doing the work. And it's vice versa, right? If your estimates are low and then plan doesn't go parallel, it will be slow because you're doing a serial execution. It could have taken the advantage of running in parallel. Memory grant is a huge implication, right? How much memory will be granted for sort, for hash tables and all that. And again, if you underestimate, your data set is not going to fit in memory. It is going to spill to the disk in TempDB, wherever the files are. And now some people might say, oh no, we have flash arrays or premium disks in cloud, but that doesn't matter. Still, you're talking about microsecond versus millisecond. So, another vice versa, if your memory grants are big, then you need other queries are going to strive for memory, is going to affect your concurrency. You might see memory grant weight, it's called resource semaphore. So that's another problem. Again, access method, seek scan or seek plus scan. How do query engine decide that? Based on the estimated numbers. What type of join I'm going to get? So, and I'm talking about physical joins, right? So say you have a small number of rows qualified for a join, or you estimated. I mean, the cardinality engine, estimated, and then you go to do the physical join. Say choose a nested loop join, but then in practical or in actually qualifies for a large number of rows. Then what happened? A nested loop join, for each row, it goes and probe the other table, and it does row by row. Very painful, very painful. Whereas if you have a large data set, really, if your estimates are correct, it would probably pick up a hash join. I'm just throwing up examples that the implications. So that is why it is important for the cardinality engine to estimate as close as possible. So a lot of inputs come from statistics, and where statistics comes from, whenever we create an index, SQL Server creates statistics. Also, without index, SQL Server can create statistics. Those are called auto stats. So if someone is querying a table or a column and there is no index, SQL Server might choose to generate statistics for that column. So this is one of the primary source for Cardinality Estimator to see how many rows will qualify. So let's look at a little bit details into that. There are 3 different sections. And if you are not sure what I'm talking about, if you get confused with the numbers, please pose it into the question and answer, and the moderator can read to me. So there are 3 sections. The first one is a header, density vector, and histogram. So let's look at the header. There's a deprecated column in the header. Do not use it. This is for backward compatibility. Microsoft doesn't recommend to use that. In future versions, they'll remove it. So as you can see, the first one is the name. When was the statistics last updated? And then you can see there's 2 things like rows sampled. But on the bottom right, you see there's something called unfiltered rows. So what that tells me is this is a filtered index and a filter, and the statistics is on that filtered index. And you can see the filter expression. It says, this index only has the records which has contact person ID more than 2000. And other thing to notice is the row sample. So because this is a small table, the statistics was updated with 100% with using all the rows. But oftentimes, if you have bigger tables like billions of records, you probably wouldn't update stats with 100% of the records, because it's going to take a lot of resources. It's going to be time intensive, and it really doesn't pay off most of the time. But you might have a edge case, so I'm not going to say never, but most of the time you'll probably create your statistics with a sample. And the header section give you an idea of what kind of sample you used. Now the steps that you see 200, that's the max you can get. So either you have a table of, like in this case is 73,000 record, it has 200 steps. Even if this table had 73 billion records, you still get 200 steps. So on a histogram, you never get more than 200 steps. Now, if you ask me how SQL Server pick up those keys for those 200 steps. There is a white paper. It's a complex algorithm. I do not understand everything in that white paper, but it's a good read if you really want to understand how those 200 steps were selected. And then it gives you a little bit more of key length information and if it's a string index or not. The next one is a density vector, and we talked about what's the density. So this index has two columns, contact person ID and order ID, and it gives you average length and the density, and I put it in the blue that how the density was calculated. And this number is important because many times you will see that in many situations this number will be used in conjunction with total number of rows in the table, and we'll see those during the demo. Now this is a histogram, and I kind of highlighted two rows. We'll dive a little bit deeper into this. And if you did not get anything out of this talk, try to understand what I'm talking right now. And if you do not understand, please pose a question. I'll go back and try to explain this again, because this is a very common concept that or very common I see that people really do not understand what these numbers mean, and that's why people struggle to understand where those estimated numbers are coming from. So look at the range high key, and that's the key for the leading column of that index, whatever it is. So if it's a person ID, say ID 2083 and 2091. So skip the range rows column for now. Go to the third column, which said EQ underscore rows. What it is saying that for 2083, I have exactly 119 rows. And for 2091, I have 106 rows. But then what does 234 and 332 means? So let's go to the next, kind of blow it out a little bit. So I talked about 2083 and 2091 equals 119 and 106 records qualify. And if you go up again, you see that 332 is in the row against 2091. So what that 332 is saying, between 2084 and inclusive 2084 and 2090, I have 332 rows. And out of those six numbers, so 2084, 85, 86, 87, 88, 89, 90, actually 7. Out of those 7 IDs, I only see you have 3 IDs in your data set. And which 3? We don't know. So, but I know there's total 332 rows and 3 IDs. So you divide 332 by 3, you get 110.66. Now, in our T-SQL query, if we pass a predicate and pass a value, anything between 2084 and 2090, SQL Server will estimate that we have 110.66 rows, and that's why it's called estimated number of rows. And you can see this right away. We know that out of those 7 IDs, 4 doesn't have any values, they have 0. But the Cardinality Estimator has no idea which 4 doesn't have any data. So you pass any of these 7, it will estimate the same number, 110.66. So I hope it's clear. If not, raise your hand, ask questions, and I can come back and explain this more. But I absolutely want to, suggest you read about this. There's many articles about this. Many people wrote about it. Microsoft has extensive documentation about this. So I'm going to move to demo, and what we're going to talk about in the demo, we'll come back to histogram every time, most of the time. We'll look at a direct hit, and when I say direct hit means if I'm passing 2083 or 2091, how those numbers get generated. If it's the interest step, meaning something in between. Scaling is something new in the new Cardinality Estimator. We look at how distinct worked and a couple of other things. Uh, so before I go to demo, I want to make tell you something that in SQL Server 2014, after a long period of time, Microsoft rewrote the Cardinality Estimator. And so if you are upgrading a version pre-2012 to anything 2014 or above, like 16, 17, or 19, you want to be a little bit more careful compared to if you're upgrading, say, between 16 and 19, because now you are really moving from an older cardinality estimator to a newer one. And Microsoft has a nice guideline how you can do that. And there's something called compatibility level. If you do not know, look at that. Microsoft is actually heavily pushing even the vendors to certify their product based on compatibility level. Not anymore talk about, okay, you're certified for 2016, 17, 19. No, they want to know what compatibility level your product is certified for. And the reason of doing this, if you go to cloud in Azure SQL database, there is no concept of SQL Server 2014, 2012, or 2019. It's just one version, but you can control the behavior based on your compatibility level. So there are some recommendations. This is not the scope of this talk, but I'm just making you aware. You can upgrade your SQL Server engine version, still keep the compatibility level to 2012, turn on query store, save some queries, then change your compatible level so it behaves with the new cardinality estimator. And then if some queries regress, you can go back and look at it, why did it regress and what happened and not. So I'm going to move to demo. That's all about the slides. So rest 30 minutes we'll spend on demo. I'm using SQL 2019 CU5. I'm using SSMS 18.5.1, and I have very strong opinion about using newer version of SSMS, because a lot of things has been exposed into the newer versions that's not available in some older version of Management Studio. And I have a whole talk for an hour or hour and a half about using new features of Management Studio. You might find it in YouTube. So if you're not using the latest version, I highly suggest you download. You even do not have to put your email address, just search for SSMS download and you will see it. Download and start using it. You will be amazed with all the new features that Microsoft added. These are some of the resources that you can read more of some of the stuff that I'll be talking about. Again, my contacts, but let's skip this and let me start the demo windows. So can you see my Management Studio? I'm just asking the moderator, or if someone can let me know, just want to make sure. Okay, I hope you guys are everybody's seeing my screen. So one thing I did before everybody came online, I ran this script, and I'm not going to run it right now. This is pretty much set up, taking worldwide importer from GitHub. I put the link and I put enough comments and instructions of what I'm doing, so you should be able to follow this. Because if we do not get through all the scripts, or if I skip some of the sections, I added some of the stuff in the comment that you can go and practice yourself. So you can set up, you can set it up yourself. So run this one first. Make sure you have the backup, downloaded, and then run this, and then you should be able to follow all my code. And all this code are in GitHub. So if you go to github.com, search for SQL Worldwide, and you should be able to download all this code as is. You do not need any permission, use it, distribute it, whatever you need to do, go ahead. And this is another script that is not really important for, not really related to the talk, but what I did here, let me run this first. So we saw some of these outputs during the presentation, right? The header and the histogram and all that. Now, looking at these numbers, sometimes people think, oh, no, there's some magic behind the scene. How did these numbers get generated? Where are these coming from? So what I did not generate all these numbers, but I did generate few of this by writing some T-SQL code and did some, did just a simple union. The reason I did that just to get the fear out of people's mind that, these numbers are no magic. There's a logic behind all these numbers, and you can generate those by yourself. So, some of the density vectors, of course, the header number, and I told you some of this, right? So a range rows, 332 between 2084 2090. So if you do a count and say give me everything between those, you get that, right? Give me all the rows count from 2083. So all I'm trying to say is, give me the distinct between this. So I'm trying to make a point that do not get afraid of, by looking at all these numbers. If you just think through this, you can generate all these numbers by yourself. So let's move on. Okay, so single predicate. I'm going to turn on actual execution plan. So there are two different kind of execution plans. One we call estimated, one is actual. The estimated one give you the same plan shape, but it doesn't have any runtime stats. Means actually how many rows qualified, actual memory grant, if it went to parallel, each thread, what it did and all that. So you can see all this, and you can turn on actual execution plan by, I put it here by Control M. Also, there is a small button here. You can use that. I'll try to, make it a little bit bigger so we can. No, I think it's big enough, so I don't want to lose my. Okay. So let's run this is a simple query. I'm saying, give me these columns from contact person 1025. And if we come here, sorry. We can see that no. Okay, I'm not going to try to do that. As you can see here, the estimated number of rows is 89. And also actual number of rows are 89. So where did this come from? We pass the value of 1025. And if we come here, 1025 equal rows 89, right? Pretty simple. Now, notice one thing that this was updated at 7:58, which is my time. Standard time. Now I'm going to insert 2,759 records and into this table. And I just want to make sure that statistics did not get updated. As you can see, still showing the old time. And do not run this in production. I'm just going to clear the cache. Just to make a point. I'm running the same query again. And hopefully I can zoom in a little bit slowly. I don't know why it's okay. No. No, it doesn't work anyway. As you can see here, the estimated number is 92.3365. And our actual number is 2848. So where did this 92 came from? because if we go to our histogram, 1025 still shows 89. So what SQL Server do when it sees that there are new rows coming in and the stats didn't get updated, SQL Server try to compensate a little bit. And I know in this case, just increase it by 3 rows, but actually the actual count was way high, but it at least takes attempt. So what it does, it goes to the histogram, get that 89, divide by the old number of rows, and then multiply by the new count. As you can see, that's how SQL Server get this 92 number. Now, let's try a different one, 1057. And if we come here, we know that 1057 is not one of the keys. So let's see what happened. Let me try to switch my screen. Just give me a minute. See if I bring this here. Does it make it any better to zoom and show people? Does not, it even doesn't. No, it doesn't do me any good. Let me try this one more time. No. Oh, it does. OK. So now we see that I know it's kind of obscured a little bit. The estimated number of rows is 123.115. And we pass the value of 57. Now, if we go here, that also doesn't make sense to me. So there's something. Let me run this again. Sorry. I'm just going to run this. Is there any question? I want to take a few seconds, maybe answer any questions if anyone has any. No. OK. Because what I was expecting on the 1057. Let me run this again. Yeah, 118.667. Run this again. OK, so I get it right. So 1057 falls between 55 and 63, right? 56 and 62. And as I said, it is going to pick up this number. It has no clue at this time. It only knows that there are 356 rows, 3 distinct divided by that, and that's what it picks up. And if we come here, we can see the actual number of rows is 109. So it's pretty close, but there can be situation that the estimated number will be 118, but the actual number can be 0 because we do not have every key in that table. Distinct works pretty good because what SQL Server does here, let's look at that. So you can see that estimated number and no, this is not working. Estimated and actual numbers both are 663. And the way SQL Server does it, as I said before, that many a times SQL Server is going to use this number for calculations, and you can see this is the same number, and it knows that there's 663 distinct values for that. So these are all single predicates. So let's move to a little bit more complex ones and see how those numbers get generated. So if you have a between condition, 2 of those, and then you want to put those two together with the AND clause. What happens? We go to the nested loop join and we can see that 44.4 was the estimate, and in fact 211 rows qualified. So where is that 44 number coming from? And this was a major change between old and new cardinality estimator. So in 2012, what happened when you had multiple predicates, SQL Server gave each predicate same weight. But in 2014 and above, SQL Server made a major change. It says, no, we should, the one that qualify for most of the rows should get more weight, and then subsequent one, we're going to do a square root and diminish the effect. And if I run this, using that formula, I think will make more sense. So here we got 44.4. So this is the formula that SQL Server is using. But in pre-2014, if we run this same query, it will only estimate 4 point something. Now, as you can see here, it's still nothing close to 211, but at least some improvement. Now, with the new cardinality estimator, can it go other way? There's a possibility. If you play with it, I'm sure you can find a edge case that it did a reverse. Same with the OR scenario. You see the estimate is 1404 and then actually it's 1235. How did SQL Server get that? Again, I put the formula here. I'm also comparing pre and post. Not really much difference, right? It's 1404 and 1492 because it also depends on your value on the on the S1 and S2, what the values are. If those values are too small, it's not going to make a big difference. And again, can you prove that this can do a damage on the newer version? Possibly you can if you try enough, but I haven't tried those edge cases and to prove that. But in general, it works better. So what I did here in a comment section with some hint, I put some code here that I'm not going to run right now for the interest of time, but you can download this and play, run this, and that should show you how these are going to perform in a scenario with the old cardinality estimator, means any version that older than 2014, so like 2008 and 12. Hopefully you don't have a 2005 that running, that you are using still. Next, I'm going to move to parameter sniffing. So if you don't know what parameter sniffing is, you can try to find out, Google it. But in a layman's term, I'm trying to explain. So when you submit a query, the query gets the hash number. And based on that hash, SQL Server goes and say, do I have any query plan against this query hash that is saved? If it's saved, it reuse it. If it's not there, it cannot find it. It will recompile, generate a new plan. And it will save that plan. Next time you submit another query, the queries look same, it generates same hash value. It will not recompile. Again, it will not generate a new plan. It will use that older plan. But you might have compiled the plan with a value that you pass first time. So you say, ID equals this or state equals this. But then you pass the same query with a different value. Maybe this value qualifies for way more record or way less record than the one that's saved. And then you have different issues with that, like some of the issues that we talked about, what kind of join, memory grants, and many things. Parameter sniffing is a big topic. People can talk about this for hours and how you solve it, but that's not the goal of this. I just want to show you how can you identify and how can you know that you are having that issue, and where are those numbers coming from when you have this issue. So I'm again using the same database. I'm creating a very simple stir procedure. Now I'm running this with a value 1025, and we have seen what 1025 does. It qualifies for 89 records. We saw that. So again, estimated number of rows 89, actual number of rows also 89. So everybody's happy. Good. Now I run this with 1057, and we ran this before with 1057. If you remember, so let's run this again on a side window, on a new window. So we know that for 1057, we are expecting 118.6667. But what happened here? Why do we still see 89? Right? Now, if you right click here, look at this. This was compiled with 1025 because that's the value that we passed when we first executed the stir procedure. But the runtime value is 1057. So still using the old estimate from 1025. Now, how do we solve this? As I said, this can be a whole talk. I'm not going to do that. But what I'm doing here is I'm getting that plan handle, and I'm telling SQL Server remove that plan handle from the plan cache. And this is a trick that you can use just to evict one plan instead of clearing the cache for the whole database or for the server. Now, if I run the same thing with 57, same store proc, this time you will see that we get the estimated number that we are expecting, 118.6667. Why? Because if you go to the properties, come to the parameter list, you can see that now parameter compiled value and the runtime value are both 57. So if you see weird issues, that your estimates are way off, you didn't expect, you might want to look at your parameter list, say, okay, are you having that issue? What value it was compiled with? Go to the histogram, look at that number. Is this number is way off than the number I just passed, right? Again, like I said, I'm not going to give you a quick one-liner how to solve this because that might not work every time, and then you might come back and say, I say that and why it's not working. So but if you have a specific use cases, send to me. I'll I know some smarter people than me. They can I can get some answer for you. Unknown is another topic, big topic for in SQL Server query execution that people deal with. It has many consequences. There are many constructs within SQL Server that when you use the Cardinality Estimator, really doesn't know how many rows can get qualified. So let's look at some of this. So here, what we're doing, we're declaring a variable, but we looked at 1025, right? It qualifies for 89 rows. We know that, but this time we are not hard coding 1025, so we're passing it via variable, right? So what happens now? Let's look at it. No, sorry, I'm actually passing the order ID, so it's different. But let's look at this. So in this case, this is good. It has, one row estimated, one actual row, which is pretty good because this is a unique column. SQL Server knows that it's unique. So, it's good. Now we are changing to, same value 1025, but we're looking at contact person ID. And let's see what happened this time. So we saw that, it was supposed to be 89, but in this case, we can see that it qualifies for 111.003. So what happened here? Why it didn't qualify for 89? So not known. SQL Server doesn't know in the compile time that what value we're going to assign to this variable. And again, it went to the density vector multiplied by the total number of rows, and it qualifies 111. So it doesn't matter what number I pass here, it is not going to change. So we can go like say equal rows, anything you pick from here. 2127. We'll still get the exact same number that we saw for 1025. Yep, 111.03. In case of table variable, things get a little bit different. So table variable, if we run this, it only knows that there's one value, but in this case it qualifies for 89. If we do a recompile, run it with the recompile, now SQL Server can get a little bit more insight and generate a number, but again it didn't generate 89, it generated 271.284. Where did that number come from? I put the formula right here, 271.3. If you're using SQL Server 2019, I'm not going to run this, I just wrote this recently. There is a new feature called table variable deferred compilation. I also put a link, read about it. In that case, you can run this without recompile, you will still get that number 271.3. There are a bunch of other things that I put in the comment. I also put some code if you are using any of these operators. They're all estimates, so they're all hard coded. You really do not have any choice to influence this. So all of this, if you go, you will see this 220078.5, 220078.5. Where is this number coming from? It's a hard coded 30% of your total rows. Doesn't matter what you pass here. For like statement, for some other, I just put these numbers and I also put the formula. You can take a look. The one that I'm not going to skip is an ascending key, which is a very common problem. If you have a table with a column that's always adding rows at the bottom, that goes beyond your histogram maximum key, right? So here my max key is 3261. And if I start adding values after that with 3262 and my stats didn't get updated, SQL Server has no idea how many rows are there. And how do you overcome that? And I talked about some trace flags. I think it's 2389, 2390. Look at that. So I put enough comment there. So I want to respect the time for the next speaker. So, he or she gets some time to come in and settle down. I'll take questions for 1 or 2 minutes. And if there is no question, I thank you for joining. Like I said, I will post the slides. Again, these are my contacts and thank you again. So I'll ask the moderator to check if there's any questions. I'll answer those. Otherwise, thank you again. I will stop and let the next presenter set up.